Good day, everyone. We are Group 3 of STEM 11B Set B from Dasmariñas Integrated High School. I am Katie Mapala, and we are going to tackle problem solving involving conic section ellipse. We will be solving a word problem, then reveal the answer and its process gradually. So, let's start. The problem that were given to us is the arc of a bridge is in the shape of a semi-ellipse with its major axis at the water level. Suppose the arc is 20 feet high in the middle and 120 feet across its major axis. How high above the water level is the arc at a point 20 feet from the center horizontally? Round off to two decimal places. We knew that the bridge has the shape of a semi-ellipse, horizontal, major axis at the water level, 20 feet arc in the middle, and 120 feet across the major axis. These pieces of information will help us later in the discourse. Now, we are going to make an illustration of the given problem. To better understand the problem, suppose that this is the look of our bridge. Next is the drawing phase. We first drew a horizontal line and a semi-ellipse, then plot the given measures. The 20 feet high in the middle and 120 feet across the major axis. Presume that the horizontal and vertical line you see is the x and y axis. For that reason, the intersection between the line is the origin. By saying that, we came up with having negative 60 and 60 at the x-axis since the measure across the major axis, which is the horizontal line, is 120 feet. The y-axis, however, is still 20 feet. Through our progress, we are now to find the equation of our ellipse. The standard form of our ellipse is x squared over a squared plus y squared over b squared is equal to 1. Since our center is at the origin, h and k is equivalent to 0, 0. We know that the value of a is the distance from the center to its vertex, giving us the value of a equals 60. To get the b, we must know the distance from the center to its co-vertex, leaving us the value of b equals 20. Now that we know the value of a and b, we notice that a is greater than b, thus giving us the idea that the ellipse is horizontally positioned. On the other hand, it will be different if it is vertically positioned. Now, our next step is to find values to be substituted into our equation. So, as what I have said earlier, a is equal to 60, b is equal to 20. Now, we now got the equation by substituting x squared over 60 squared plus y squared over 20 squared is equal to 1. It will give us x squared over 3,600 plus y squared over 400 is equal to 1. Promptly, we can now answer the given question. How high above the water level is the arc? At a point 20 feet from the center horizontally, and from the center, we need to move 20 feet. because our main goal is to know the height of the arc from the point we just made. Let's just call the line we drew H and the point it marked at the ellipse be 20h equal to x and y coordinates. Now, to our next step, substituting the values we derived from our illustration to the equation before solving for h. After doing so, we will get 20 squared over 3,600 plus h squared over 400 is equal to 1. Let's simplify and we will get 400 over 3,600 plus h squared over 400 is equal to 1. Get the lowest term and we will get 1 over 9 plus h squared over 400 is equal to 1. Now, we will subtract 1 over 9 to both sides and we will get h squared over 400 is equal to 1 minus 1 over 9. Then, let's focus first on the right side of the equation. Subtract 1 to 1 over 9. Since this is the similar fraction, we're going to find their least common denominator or the LCD. It will give us the answer 8 over 9. Now, our equation is h squared over 400 is equal to 8 over 9. Since we are looking for the value of h, let's multiply both sides to 400 para maiwan si h sa left side. So, h squared over 400 times 400 gives us h squared, and then 8 over 9 times 400 gives us 3,200 over 9. So, we get h squared is equal to 3,200 over 9. Now, to get the final answer, the value of h, get the square root of both sides. So, square root of h squared is equal to the square root of 3,200 over the square root of 9. Simplify and it will give us h is equal to 40 times the square root of 2 over 3. And if we put 40 times the square root of 2 over 3 on our scientific calculator, we will get approximately 18.86. Thus, h is approximately 18.86 feet. Therefore, we conclude that 18.86 feet is equal to the height of the arc at a point 20 feet from the center, which satisfy our problem. Again, we are Group 3 of Set B, and thank you for listening.